Hey everyone, welcome back. Here we go, episode 2. So yeah, kicking straight on from yesterday's. If you haven't seen episode 1 with regards to the Hambini Engineer of Lies, I would recommend going and doing so. Otherwise, zooming straight into it in part 2 may not make a lot of sense. The super concise recap on where we're at the moment is I am correcting a frankly astounding amount of just utter BS and misdirection and lies. At the moment, we're still just in a weird spot around bearings and tribology. The entire thing is basically boils down to this is all Hambini avoiding showing how he tested the ceramic versus steel bearings. That is it. So all of that crap we've covered so far, and this next section of crap that I'm going to be going through, all boils down to him trying to hide behind all this rubbish to not show how he conducted this testing. Amazing. All right, let's kick on. Alrighty, we're up to here in his manifesto of BS that he's typed out. We're going to skip past a fair bit of this bearing stuff for the moment because I'm going to be going or doing a separate episode or episodes on his versus me bearing information and his bearing testing. So yeah, just basically stay tuned on this, otherwise it's just going to bog things down. However, things I guess are a bit relevant here just in terms of easily provable BS that he's put in this document. Alright, the ceramic bearing narrative. Adam Karen later published a 27-page article attempting to justify his support for ceramic bearings, but it was riddled with amateurish inaccuracies and misconceptions. He continued to harp on the supposed fishy marketing due to the lack of openly available information, failing to grasp the costs, standards are expensive, complexities, and proprietary nature of the data he was seeking. So again, this is Hambini hiding behind the fact that he's not willing to release how his bearing data was obtained or tested. In 2004, Schaeffler, through their bearing brands, developed a martensitic hardened steel that would later carry the trade name Chronotech. This material was exclusively used for Campagnolo for 2 years from 2008 in their super record bottom brackets. Schaeffler conducted extensive testing of several million cycles to validate the product's performance in comparison to their regular offering. They were a supplier to Hope at this time. This segment of Schaeffler's business would eventually evolve into Schaeffler Velo Solutions. Alright, so we've got a couple of lines of just, astounding BS to cut through there. The first one is, it's not like I would have been unwilling to purchase a test standard. Had he named a test standard, I would have gone and purchased it. There is no ASTM or other test standard for cycling bottom bracket bearings. So what was the test? Now, if it's Schaeffler's own invented test, their own proprietary test, because they have wanted to develop, I guess, a segment of their business that is going specifically into cycling bottom bracket bearings, then if his data is from Schaeffler's proprietary test, then that's, I guess, a different point. And it's kind of interesting that I'm only hearing about that now. Obviously, his data and information at the time should have referred to that this bearing test data is from Schaeffler's own proprietary bottom bracket testing. But I guess, interesting that that's just come up now, but also interesting in that how come then Schaeffler have thus used the test to develop hybrid ceramic bearings with martensitic hardened steel races, obviously now sufficiently hardened to be able to handle the rigors of running the hybrid ceramic, or the ceramic balls. So he's used potentially Schaeffler's own, or like a proprietary test for his bearing data, where his information says that this bearing testing proves that hybrid ceramic bearings are basically a con. They damage the steel races in basically within 500 kilometers and become higher friction than steel. And yet this test has been used by Schaeffler, who I guess apparently invented it or created it, to prove to themselves that their martensitic hardened steel races with hybrid ceramic balls are awesome. And they have now gone and created an entire velo division around this and started supplying hybrid ceramic bearings to Campagnolo and Hope, which just completely contradicts everything that that Hambini has put forward. So the bringing in Schaeffler's proprietary test that they have used to develop hybrid ceramic bearings, which are awesome, and then create a velo cycling division around that, how does he then use their testing, if that's what is used, to go to market to say hybrid ceramic bearings are a con, buy steel? It is a just complete and utter contradiction. So whichever path he's wishing to choose, either there was no test for me to purchase anyway because there is no standards testing, or he's used Schaeffler's testing, which they themselves have used to prove how awesome hybrid ceramic bearings are as long as the races are of sufficiently hardened quality steel. So yeah, it's like a choose your own adventure path of bullshit. Path A bullshit, path B bullshit. Which one is it going to be? The other thing that's just utterly ridiculous about all that is martensitic steel is patented in the early 1900s. Is he seriously trying to say that only Schaeffler figured out at around 2008 how to do martensitic hardened steel races in bearings? That is so bonkers. There has been it's often you'll hear things referred to as either sort of case hardened or face hardened parts. They can be gear cogs, obviously bearing races, a whole bunch of stuff. I mean, martensitic steel has been used for so many applications for so long. To try to paint the picture that Schaeffler have pioneered this new bearing race using this martensitic hardening technology, which was patented in I think about 1919, and that no other hybrid ceramic bearing manufacturer is doing this, you can rank that yourself on your own bullshit meter, but let me tell you, it's going to blow it up. Alright, so now it's possible what he meant to say but didn't was that Schaeffler were specifically marketing a improvement in their previous level of awesomeness around their how hard their steel races were, and they're calling this new Chronotech technology, and they've done this specifically focused for hybrid ceramic bearings to be able to withhandle the rigors of cycling. But if you think that they are the only manufacturer that have been working on making awesomely hardened steel races for awesome hybrid ceramic bearings, again, the bearing industry is massive, and that is just nuts. A competing example would be, say, Enduro with their XD15. Yeah, those bearings are practically indestructible, and Enduro I've obviously been making a astoundingly hardened and durable steel race for quite some time using a particular type of steel. Ceramic Speed would lay claim that their hybrid ceramic ball races are extremely hardened, and they offer a lifetime warranty on their coated, and I think it's 4 or 6 years on their non-coated. You won't get that from any steel ball bearing. So it's pretty nuts to paint a picture that only Schaeffler was able to make steel races hard enough to survive running hybrid ceramic balls, and even that in itself goes against his entire hybrid ceramic versus steel presentation, which goes into none of that. All of it was telling you that basically all hybrid ceramic bearings are going to be screwed after basically about 500 kilometers, becoming higher friction than steel. They're an industry-wide con by the quality steel that he happens to be selling. And before you start yelling at me about the costs and no one should be paying what some of these hybrid ceramic bearings are worth, you can buy X number of sets of steel bearings and so on. The economics of should you be purchasing hybrid ceramic or steel, we're not going into at the moment because we can bog down that. The point that we need to cover here is that hybrid ceramic bearings simply are awesome as long as the races are sufficiently hardened and the ceramic balls of sufficient quality. The high-end hybrid ceramic bearings, they are not being damaged after just 500 kilometers. Because what the heck would be the point in making those bearings? And obviously the real world lifespans that just countless, tens of thousands, hundreds of thousands globally are seeing from their quality hybrid ceramic bearings, if they are still silky smooth after 10,000 kilometers, 20,000, 30,000 kilometers in your BB, can be 50,000 kilometers or more in your, in your wheels. If they are still silky smooth with just basic re-grease maintenance, guess what? Those racers have not been damaged after just 500 kilometers. Because if they were, they would be, bearing damage is cascading. Once damage starts, it starts off relatively slow, but that damage causes further damage, which causes further damage, and past a certain point, you get a cascading failure that's quite rapid. If the harder ceramic balls were damaging the comparatively softer steel racers after just 500 kilometers and becoming higher friction than high quality steel, let me tell you, they would not be feeling beautifully smooth after 10,000 kilometers or 20,000 kilometers or 30 or 50. Just that premise that he has put through, and that is the pivotal key part of his hybrid ceramic versus steel bearing presentation, and the foundation point telling you that hybrid ceramic bearings are an industry-wide that is utter BS. So we're not going into the economics of should you be buying high quality steel or spending the big extra jump to hybrid ceramic. Separate discussion. For a lot of people, high quality steel is all they will ever need or should purchase. Just talking about the facts of whether they're an industry-wide and being damaged after 500 kilometers or not, it's just it is off the scale of bullshit meter, and I think we can start to see what the industry-wide is, and it isn't hybrid ceramic. Moving on. Despite the well-documented marketing material produced by Schaeffler, Karen has repeatedly claimed these tests never took place. Likely he could not find it on Google. Well, it would have been nice if he referenced it if that's the test he used too. Even though it's widely known that this type of bearing has specific applications, namely inner ring interference only due to its poor shock performance, Campagnolo has generally only used the bearing in inner race interference applications. Yeah, so again, if he's ribbing me for not knowing of the Schaeffler testing, he should have put that in his presentation and information. And also in the discussion that we had back and forth all those years ago. Possibly the reason why he didn't is because, why is he bringing it up? Because everything points to the fact that their testing supports my argument that hybrid ceramic bearings, as long as the racers are sufficiently hardened, are amazing. They created apparently an entire cycling-focused division around their awesome hybrid ceramic bearings. So why is he using that in the argument? He's self-defeating his own points. And then to say that they only use them in inner race interference fit on, for instance, like Campagnolo ultra torque cranks. What are these then? Let's have a look. What do we have here? We have a Campagnolo hybrid ceramic bearing hub using what they call their Colt bearings. These hubs using their Colt bearings have been out for I don't even know how long. So hybrid ceramic bearings by way of they have ceramic balls running on hardened steel cup and cones. So how are your Colt bearing hubs going if you have Campagnolo wheels, or if you have Fulcrum, which is a sister of Campagnolo? They refer to those as USB. So they use they are hybrid ceramic balls used on the same basic cup and cone hubs. So to say that they're only using such for inner race interference fits, such as their ultra torque cranks, is just, how much so easily proved utter BS do you need with regards to him on the hybrid ceramic versus steel bearing front? It's a mountain. So, a short summary on all of that, where he has been saying that hybrid ceramic bearings are unsuitable for uses in cycling, obviously in the wheel application due to vibration and shock. You can shove that right back up the clacker from whence it came. At the end of the day, as long as the hardened steel race has the sufficient dynamic load rating to not be damaged by the level of shock and impact that it's going to be subjected to in your cycling, it will not be damaged or indented by the very hard ceramic balls. And there's a number of reasons why the hybrid ceramic balls will outlast. The balls are typically the faster wearing part within the bearing, and the balls are harder, so they wear less. They are also, the high quality ones, smoother and rounder, so they cause less damage to the races over time, which steel bearings will wear the races at a greater rate due to the fact that they are less round and smooth. Steel bearings also deform more under high shock loads, and when they have some deformation, if they're not a very smooth round ball running on the races, they will cause more damage to the races. The very hard ceramic balls deform very little under the same shock load, if at all, and therefore protect the races from being damaged by them still being round. It all comes down to the quality and hardness of the steel, the quality of the ceramic and the smoothness of the ceramic versus the steel balls, the dynamic load rating of the bearing. As long as that there is a lot of safety buffer on that dynamic load rating of the bearing, the shock and vibration loads that it is then subjected to, if they are well under that dynamic load rating, the bearing is going to be fine. And what do we see with these bearings in real world use over tens of thousands of kilometers? Is that they are fine. If there was an issue with vibration and shock loads going through these hybrid ceramic bearings in our wheels, we would bloody well know about it. I mean, my God, it's just such utter rubbish. So all this bullshit he's going to try to point to with Brunelli and false Brunelli, again, he can just shove it right back up where it comes from, because he has painted the most mountainous amount of BS and misdirect with his whole bearing talk, that without even doing the bearing episode, I think you're hopefully getting the idea. If you never make it that far in, hopefully I've given you enough just in this episode here that you know who's telling utter BS to sell high quality steel and who is not. Okay, back to the manifesto of BS. This dialogue made it abundantly clear that Karen had little knowledge of SN curves, the basic loading calculations of bearings, or test standards such as Fafnir testing. He also has the deluded mindset that a competitor, Hambini Engineering, would provide this data and knowledge for free. I mean, alright, we'll go into more of that depth on that in the bearing one, but at the end of the day, it's his data that he's used to put to the world that hybrid ceramic bearings are a industry-wide con, will be damaged after 500 kilometers, and buy quality steel from him. He should be substantiating the data for that testing, because it's pretty wild kind of data and a pretty wild bunch of information that he's pitching to the world. Now, if that data is not generated from his test and it comes from Schaeffler and it's their proprietary test, I mean, after all we've covered, that does not seem likely, because Schaeffler used their own proprietary test to go into the market of selling hybrid ceramic bearings. So I have no idea why he's introduced all of that. It is the most stupid contradictory tree that we've just had to go through and unpack for you, I think, that I've seen in cycling thus far. So if it's not Schaeffler's testing, which again would be unlikely, from the fact that they used it to go into hybrid ceramics and sell to cycling, then it's either his test data that he's created a test of 10,000 kilometers for cycling, or, as has been my concern, if he won't provide the details of that, has he just, input the data that he wanted? I'd hope that's not the case, but he's not giving me anything, and has never given me anything to rule that concern out. Now, the deluded mindset that a competitor, Hambini Engineering, would provide this data and knowledge for free. Remember, and he's even put it in this document himself, at the time I was discussing with him with regards to stocking Hambini bottom brackets. I'm not a competitor in the space. I don't make bearings. I don't sell my own bottom brackets that I create. I was stocking same with what we do with lubricants. I wanted to stock the genuine best bearing options for my cycling customers that I could find. And so I had a number of bearing manufacturers that I would be getting bearings from, being Ceramic Speed, HSC, Kogel, and Enduro. And from Enduro, we would do a lot of steel bearings as well as hybrid ceramic. And I was looking to potentially add the Hambini bottom brackets to that lineup of offerings. So I'm discussing with him, not as a competitor, but as a retailer of his bottom brackets. But I just wanted to understand the data behind what he was pitching, because I thought it was all pretty wild. So somebody, who's looking to become a retailer of your bottom brackets, I do not believe is a competitor. Okay, back to the manifesto of BS. This dialogue made it abundantly clear that Karen had little knowledge of SN curves, the basic loading calculations of bearings, or test standards such as Fafnir testing. He also has the deluded mindset that a competitor, Hambini Engineering, would provide this data and knowledge for free. I mean, alright, we'll go into more, not as a competitor, but as a retailer of his bottom brackets. But I just wanted to understand the data behind what he was pitching because I thought it was all pretty wild. So somebody, who's looking to become a retailer of your bottom brackets, I do not believe is a competitor. Okay, even basic calculations are wrong. Karen's continued shallow depth of engineering extend further as he incorrectly states torque, turning force, times RPM equals power. This statement is fundamentally incorrect. Power is calculated as the product of torque and angular speed in radians per second for SI, not simply RPM. Even the most junior engineering students would recognize this basic principle. Karen also claims that power and loss can be measured directly, disregarded the fact that power is not a fundamental unit within MLT, mass length time, or FLT, force length time systems. It must always be calculated and is typically timed. Similarly, friction does not have standalone units. It is a coefficient and is always derived through calculations, despite his assertions that it can be measured directly. These misstatements highlight a significant lack of technical understanding, raising concerns about his authority on such topics. Alrighty, so this one falls into more the cheap shot category. I struggle for length on explanations in both documents and video as it is. So I think that me using, where I can, simple terms for the layman, such as power equals torque times speed, I'm going to do that. For what I do, I'm not reviewing power meter accuracy or power meters. I don't need to go into angular velocity and how many times a power meter is measuring that per second. That's for other fields like, say, the awesome work that GP Llama does and DC Rainmaker. For what we need to know on what I do, we need just a simple explanation. And I think that power being torque times RPM suffices just perfectly, and it is a simple explanation that is used by many, many places when they're talking about power, because it is something quick and easy for everybody to be able to understand. We don't need to go into angular velocity and radians per second. Jesus. Now, all that other engineering babble he put in there about measuring power directly. So information on other test facilities, because I have never obviously claimed to measure power directly, because I do not do outright efficiency testing. I'm really unsure what he's trying to tear down here. Is he tearing down the likes of when I've covered, say, friction facts and ceramic speed using 6,000 USD cost torque sensors at the drive and braking shaft, and measuring the loss in between those two sensors as how they determine the losses in the chain? So does he have issues with that methodology that I've covered in the past? So I guess throwing out crap about me being the one to claim that power and loss can be measured directly is quite weird. I've covered others' work in this particular area of cycling, and it's a big focus from many facilities that are focused on measuring efficiency loss, from friction facts to ceramic speed to muck off to wheel energy to Silka. Silka are using, so most places will either be using watts loss or an efficiency loss percentage. So again, from what we're looking to understand at our level, we simply see that there will have been X power input and then X amount of watts or an efficiency loss percentage. So like, the attack here, in my opinion, is a very cheap, poor level to try to discredit me for using basic terms and principles for the basic understanding for any readers that would need to have with regards to efficiency losses for chain, lubricant, bearings, and again, any such testing for efficiency losses is done by other facilities, not by me. So what does he mean by lack of technical understanding claiming to be an authority? Since I do not do outright efficiency testing and do not claim to be able to measure power and power loss directly, this does not make sense. I do cover a lot of published knowledge in the field, hence why I've covered the use of FTT and FLT testing in the past, the pitfalls that many facilities fall into using only FTT testing for long runs, the pitfalls of using electrical power consumption, such as volts times amps to test for losses that I've seen others use, and the feedback loop issues they get into with that, and also the issues of using power meters to try to measure chain and lubricant efficiency because they're just simply not accurate enough. I don't need to be, and you don't need to be, an engineer to, either for me to cover such testing and explain that to you, and for you to read it and understand it. And if we're using simplified, examples and terms and explanations, that's what is done for most technical areas, because people would be, I think, switched off by full engineering explanations on many things. So, yeah, that basically whole paragraph, I think, was meant to appeal to his readers. He just put a lot of what I'm sure he is clapping himself on the back for sounding very officiously engineering and trying to make me look like an idiot. But, let me know if he hit the mark or missed the mark there. I really don't get it. So, an example from this would be, say, for instance, an excellent mountain bike rider and mountain bike field tester. They do not need to have a mechanical engineering degree to understand suspension kinematics, to understand it themselves and to explain it in simplified terms to their readers or viewers. They do not need a degree in fluid dynamics to know when a shock is performing poorly or extremely well, talk about dampening, rebound rates, the whole lot. They can do that just by spending some time learning the particular focus that they're interested in and covering for their readers. So, how many cycling articles would be torn apart for the writer or presenter using basic principles and terms to cover what the audience needs to know? It's probably 99.9% of tech articles. So, yeah, that paragraph, I think we're going to put it down as engineering babble to try to have a cheap shot. Then comes back to the bearings and vibration. So ceramic bearings are notoriously poor performers under shock and heavy loading, which is why they're not suitable for applications like car wheel bearings and power tools. And all right, so basically we'll put this down still as blah, 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 blah. We'll be able to completely disprove all of that in the bearing episode, that this whole bearing crap has gone on long. He weirdly tries to use one of the bearing companies that we used to sell their bearings as their own information as his proof. Therefore, under heavy load or even some impact load, the endurance life of a ceramic bearing could be equal or even shorter than a steel bearing. How was that proof of his argument? Again, we will cover, it all comes down to what that dynamic load is, or shock load is, versus the bearing's load rating. That's obviously rather critically important. Larger bearings have a higher rating than others. A hybrid ceramic bearing being equal or even shorter than a steel bearing still has nothing to do with hybrid ceramics being an industry-wide con and being damaged after just 500 kilometers of cycling. So trying to use, information that HSC have put out of context, and they sell just hybrid ceramic bearings, not steel. Wouldn't it be weird if they just undermine their entire sales strategy? So again, he's just doing a whole bunch of weird stuff to try to prove an unprovable point. Kieran's comments on the matter: quality hardened steel races are not troubled by harder ceramic balls in cycling application due to vibration. Yes, correct. Much proof in the next episode. Had Kieran taken the time bearing episode I should say, had Kieran taken the time to read the recommended material, he would know the difference between Brunelli and false Brunelli, and again, blah, 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 blah. We're going to cover all that when we get to the bearings, but that's all rubbish. He would have also understood why plastic cages are a poor choice for highly loaded bearings. All right, what do you call a highly loaded bearing? And loaded in a way that it's putting stress on the cage. The cage is there to maintain separation of the balls. So sometimes a certain strength of cage is needed to ensure that the balls are going to be separated. That is not the case in cycling. We just do not put, what he is calling highly loaded in the context of stresses on cages, which is why just about all of the high quality bearings in cycling, be they hybrid ceramic, or even the higher quality steel. So above a certain level, Enduro will move from a steel cage with their ABEC 3 level bearings to a polyamide cage in ABEC 5 very, very quickly, because we're going to cover all this properly, but since we're just on this mountain of bullshit. For cycling, and this was confirmed by a very large independent bearing manufacturer, in cycling it is very likely that the lubrication level within the bearing will reach a low level, because we are typically fairly slack with regards to our re-grease maintenance. There is vibration in cycling. The last thing you want is a steel cage when a bearing is going to be subjected to a low lubrication level and vibration. It is just bad, versus the self-lubricating polyamide cages. If the polyamide cages are sufficiently strong, and they are, who's had trouble with their bearing separation in their polyamide cage bearings in cycling, then the self-lubricating polyamide cage is vastly the superior choice for cycling, where it is going to encounter both vibration and likely at some point to encounter low lubrication levels. I had to edit my own swearing out. Alright, so sorry that, we'll call this one here. Sorry it's been still so focused on bearings for the non-bearing episodes yet. But even in just covering the main parts there, I mean, we've been able to, I think, very clearly highlight some pretty astounding level of both hypocrisy in his own arguments and dishonesty. And so even if you don't make it to the deep dive on the whole bearing BS stuff, I hope that you've still at least now had some balance to the argument with regards to hybrid ceramic versus steel. If you had previously been sold down the river with regards to the fact that hybrid ceramic is just a pure industry-wide con. This whole bunch of previous BS that I had to cover mostly across episode 1 and 2, all of it comes down to the fact that he has not, will not, and just does not want to release the testing that sits behind the data that he has used to tell the world that hybrid ceramic bearings are an industry-wide con. Buy quality steel from him. That is it. Obviously, he's tried for a twofer at the same time. So whilst not pitching out there to the world that all of this is him hiding behind not releasing his testing for the bearings, he's just tried to make me look like an idiot whilst he's at it. But I hope, if you've followed all this okay, that you have now sufficiently seen through all that for what it is. And just to perhaps finish this one off with a little bit of humour for the day, all of what he has said with all that fluff and BS, I think we can it makes about as much sense as what I'm about to play you now.
Basically, the only new principle involved is that instead of power being generated by the relative motion of conductors and fluxes, it's produced by the modial interaction of magnetoreluctance and capacitive diractance. The original machine had a base plate of prefamulated amulite surmounted by a malleable logarithmic casing in such a way that the two spurving bearings were in a direct line with a panametric fam. The lineup consisted simply of 6 hydrocoptic Marsal vanes, so fitted to the ambifacient lunar wane shaft that side fumbling was effectively prevented. The main winding was of the normal Lotus-O deltoid type placed in panendermic semi-boloid slots of the stator. Every 7th conductor being connected by a non-reversible Tremi pipe to the differential girdle spring on the up end of the gram meters. Moreover, whenever fluorescent score motion is required, it may also be employed in conjunction with a drawn reciprocation dingle arm to reduce sinusoidal depleneration. The retroencabulator has now reached a high level of development, and it's being successfully used in the operation of Milford trunnions. It's available soon.
Perfect summary of what has been in Hambini's document so far. Thank you for bearing with me for episodes 1 and 2 if you've made it this far, and I look forward to episode 3. We actually get to talk about ZFC. Yeah, alright, till the next one. Thanks all for the comments and support so far on episode 1. That's been fantastic.